Okay, welcome. Today we shall be discussing quadrilaterals and polygon. As a technologist, we deal with different shapes. We use shapes and signs and symbols to communicate. So it's important we, take to notice different types of quadrilaterals that we have, different shapes that we have in technology. So by the end of this topic, I expect you to be able to explain quadrilaterals and give at least 4 examples of quadrilaterals. I also expect you to define polygons and give at least 4 examples of polygons. Okay, what exactly is a quadrilateral? A quadrilateral can be defined as a closed two-dimensional shape which has 4 straight sides. The name quad means 4, lateral means lines. So any shape that has or that is bounded by 4 straight line segment is a quadrilateral. So any shape you see that they have 4 sides, that shape is called a quadrilateral. I need you to take note of that. Okay, so we have different examples of quadrilaterals. Quadrilaterals can exist as a kite, a rectangle, a square, a trapezium, a rhombus, a parallelogram. They are all examples of quadrilaterals. Okay, so let's look at these quadrilaterals I've mentioned and talk about their properties so that when you see them, you can identify them. You can say from the properties that, oh, this quadrilateral, it's actually a rectangle, it's actually a trapezium, it's actually a square, it's actually a kite, it's actually a rhombus. By different properties we are going to highlight at this moment. Okay, for a rectangle, it has 4 sides because it's a quadrilateral. Okay, it also has 4 angles, and these angles are all right angles. All right, so because for every quadrilateral, the sum of its interior angle is equal to 360 degrees. So for a rectangle has 490 degrees, 4 angles, and they are all 90 degrees. Okay, the opposite sides of a rectangle, they are congruent. Opposite sides of a rectangle, they are equal and parallel. So if you look at side AC is equal to side BD and parallel to it. There's nothing that will make these 2 lines to ever meet because you know that parallel lines don't meet. Side AB is equal to side CD and parallel to it. Okay, for a rectangle, it has just 2 lines of symmetry, which means that it has 2 lines that divides it into 2 equal parts. The diagonal of a rectangle is not a line of symmetry because it does not bisect the angle 90 degrees. So don't confuse it with a square. A rectangle has 2 lines of symmetry. The diagonals don't bisect the angle 90 degrees. Therefore, the diagonals of a rectangle cannot be taken as a line of symmetry. Please take that into consideration. Okay, for a square is also another example of a quadrilateral. For a square, all sides of a square, they are equal. A square has also 4 interior angles, which are all 90 degrees. I already told you that for a quadrilateral, the sum of the interior angles is equal to 360 degrees. So for a square, 90 plus 90 plus 90 plus 90 will give us 360 degrees. A square has the opposite sides are parallel. Of course, they are equal and parallel. The other opposite sides are equal and parallel, all right? All sides are equal for a square. And a square has 4 lines of symmetry. You can divide this square like this. We have these 2 sides is equal to these 2 sides. This side is equal to this side. You can also divide a square like this. What we have here is equal to what we have here. The diagonal of a square is a line of symmetry. The 2 diagonals here are lines of symmetry because they bisect this angle 90 degrees. They bisect this angle 90 degrees. Bisection here simply means they divide the angle 90 degrees here into 2 equal parts. Okay, so for a square here, you can see from here that diagonals, they bisect each other at angle 90 degrees. That's what we see obviously about a square. It's important you know this about a square. It's very, very important you know it. A trapezium is another important quadrilateral that we have. For a trapezium, no side of a trapezium is equal to the other side. It has unequal sides. A trapezium has unequal sides. It has a pair of parallel sides, although, like I said, these 2 parallel sides are not equal, but they are parallel to each other. If you consider this side and the whole of this line segment, they are parallel to each other. They cannot meet, but they are not equal. That is that for a trapezium. A trapezium has no line of symmetry. As a matter of fact, we can consider a trapezium as an irregular shape because no side is equal. So just like other quadrilaterals, a trapezium, the interior angle of a trapezium is equal to 360 degrees. So please take note of that for a trapezium. When you see a shape like that, that has these properties I've outlined, just know that the shape we're considering, it's a trapezium. We also have another important quadrilateral we call rhombus. A rhombus is that quadrilateral that have all sides equal. It behaves like a square, you know. A square has all sides equal. A rhombus too has all sides equal. All each sides are equal, right? These opposite sides are also parallel. This side is parallel and equal. Okay, so for a rhombus, it has the diagonals of a rhombus serve as lines of symmetry, and they bisect each other at angle 90 degrees. So you can see that this diagonal bisect each other. What that simply means is that if we have this diagonal QS and diagonal PR, if diagonal QS cuts across diagonal PR, it will divide diagonal PR into 2 equal parts, so that distance from OR is equal to distance from OP. They are of equal distance. Same thing too with diagonal QS and diagonal PR. All right, diagonal PR divides diagonal QS into 2 equal parts. So OS is equal to OQ. It's important you take note of that. Okay, so like I said, diagonals are perpendicular to each other. The diagonals of a rhombus, they are perpendicular to each other. Simply means they are at right angle to each other. They are at 90 degrees to each other. So these are different properties of a rhombus you should take note of. For a kite, sometimes you may mistake a kite to be a rhombus, but just like what we have, there are differences between a kite and a rhombus. At least for a rhombus, you should know that all sides are equal. But for a kite, it's just the adjacent sides that are equal. That's for a kite. The adjacent sides of a kite, they are equal. Okay? The diagonals of a kite, they are also perpendicular, just like what we have in rhombus. Okay? No vertex angle are congruent. Vertex diagonals bisect the vertex angles. I hope you understand what that means. Bisection means it divides it into two equal parts. So the diagonals, the vertex diagonals bisect the angles into two equal parts. We should take note of that. Okay? Vertex diagonals bisect the non-vertex diagonal. They divide them into two equal parts, like we have here. Okay, having considered these few polygons, these few quadrilaterals, it's important we look at polygons. What exactly do we mean when we say a polygon? A polygon is a plane shape that is bounded by more than two line segments. For example, a triangle is a polygon. Quadrilaterals, they are polygons. We also have different examples of polygons. Polygons, like you know, they are two-dimensional shapes. They are plane shapes. All right? They are plane shapes. They just connect each other to form their different shapes and their names. But you see, this shape you're seeing here on the screen is not a polygon. The reason is because it's not closed. But we have here is a polygon. This one is not a polygon because it has a curve. Polygon has straight line segments. They are bounded by straight line segments. We don't have curves. When you have curves, they are no longer regarded as polygons. When they are not closed, when the shape you've seen are not closed, they are no longer regarded as polygons. These are a few things you should know about polygons. We have different examples of polygons. I've mentioned before, a triangle is a polygon. All the examples of quadrilaterals I've given already, they are all polygons. We also have other polygons like hexagon, pentagon, octagon, and so on and so forth. They are all examples of polygons. We have different types of polygons. We have regular polygons and irregular polygons. At this level, we're going to stop it there. We have regular polygons and irregular polygons. Polygons that are regular polygons are polygons that have equal size and equal angles. Such a polygon is known as a regular polygon. All sides are equal. All angles are equal. We call such polygon a regular polygon. Example of such regular polygons, they include an equilateral triangle. An equilateral triangle has all sides equal and all angles equal. So such a polygon is regarded as a regular polygon. A square is another example of a regular polygon because all sides of a square, they are equal. They also have equal angles. I hope you can understand what we're saying here now, right? Okay, so we also have other regular polygons like heptagons, the regular pentagon, the regular hexagon, the regular octagon, the regular nonagon, and so on and so forth. They are all regular polygons. We also have other type of polygons that we call irregular polygons. They are called irregular polygons because they don't have equal size, they don't have equal angles, so they are irregular. All right, so even the orientation polygon, they can also be classified as irregular polygons. Just like I said, at this stage, we'll only limit ourselves to the two types of polygon, regular and irregular polygons. So for this, you see on the screen, there are examples of irregular polygons because they have unequal lengths. All right, their lengths are not equal. See, a rectangle is present there. Rectangle is a polygon, but an irregular polygon. We also have this reentrant polygon we have here, and other types of triangles that are not equilateral triangle. A scalene triangle is an irregular polygon. We also have this irregular pentagon here. We have the trapezium. They are all examples of irregular polygons. I trust by now when you see polygons, you can actually identify them. Now, we have different names that we'll give to polygons depending on the number of size. I'm going to lead you to the first 10 polygons and their names. Of course, they are simple and we can memorize them. All right? Like I said, any shape that does not have more than two means starting from 3 and above, okay, is not a polygon. It's not bounded by more than 2 line segments. It's not a polygon. So the first polygon on our list is a triangle. I need you to understand that a triangle is a polygon. Then the second, because it's 4-sided, is a quadrilateral. Quadrilateral, they are polygons. Then a 5-sided polygon is called pentagon. All right? And a 6-sided polygon is called a hexagon. 7-sided polygon is called a heptagon. 8-sided polygon is called an octagon. And 9-sided polygon is called a nonagon. 10-sided, like that, a decagon. Deca means 10, like that, like that. Okay, having said this, I trust that you can now identify polygons and identify quadrilaterals based on these few properties I have outlined. Okay, having said this, I want to guide you through to our ExamGuide app. This app, like I told you earlier, is the app I recommend for anyone who wants to smash, in Nigerian language, his basic examination. I need you to know that this app is the app you need, because the more you practice with this app, the more you perfect certain aspects of your subject area. Okay, let me walk you through to the app to see how we can use this app to answer a few questions that are based on what we've just done now. Okay, so let's look at 2022 basic examination paper 2. Number 6 said, what is G in the quadrilateral drawn below? This shape we'll see here is a quadrilateral. From what we are seeing, we can easily name this quadrilateral because there's something that I told you already, right? This type of quadrilateral, you can see that these sides are parallel, these two sides are parallel, and they look equal. So this is a typical parallelogram. Now, this line that runs from A to D, labeled G, is known as a diagonal. the diagonal of the parallelogram. That's what that label is called. The G there is called diagonal, that which is option A. This is 21. A polygon bounded with 9 sides is called option A, heptagon, option B, hexagon, C, nonagon, D, decagon, E, pentagon. Heptagon, 7-sided, hexagon, 6-sided, decagon, 10-sided, pentagon, 5-sided. So from this elimination method I have used now, I trust you already know that the right answer to that question is option C, which is a nonagon. Thank you. See you again.